Today we're going to talk about the normal distribution. And one type of probability distribution is the normal distribution. And when we say the word normal, we're actually talking about symmetrical. The graph of a normal distribution is a bell-shaped curve called a normal curve that is symmetric about the mean. So let's write down that definition. A normal distribution is a continuous, bell-shaped, symmetric about the mean. And in this case, our mean, median, and mode are all around in the same place, okay, since it's symmetrical. Remember, mean is the average, median is the middle, and mode is the majority or most. Okay, so here we have a picture of the empirical rule or the normal distribution. Okay, and we can see a bunch of different symbols on here. So let's talk about these symbols first before we go into the properties of a normal distribution. Okay, there's this little symbol right here. That symbol is mu. It's a Greek letter and it stands for the mean. There's this other symbol on here that is called sigma. It's a Greek letter and it represents the standard deviation. So when you look here at the middle, we have the mean, okay? And if we add one standard deviation, we're over here to the right. If we subtract the standard deviation, we're over here to the left. So that's what these little symbols are talking about. And then this is saying it's going to the left 2 standard deviations and to the left 3 standard deviations. So that's what these little symbols represent. The area under the curve, the total area is 1. 68% of that area lies within 1 standard deviation. 95% lies between 2 standard deviations of the mean, and 99.7% lies between the 3 standard deviations of the mean. Okay, so that's what all of those mean. So let's write those down so we can remember that the total area under the curve is 1. Okay, about 68% of that area lies within 1 standard deviation of the mean. 95% lies within 2 standard deviations of the mean, and 99.7% lies within 3 standard deviations, I'm going to abbreviate here, of the mean. So how do we use the normal curve or these percentages? Let's look at this example. The heights of players in a basketball league are normally distributed with a mean of 6 foot 1 inches and a standard deviation of 2 inches. So on your notes, I don't think you have this chart drawn, but you'll want to draw it. So you start by drawing this line right here, kind of like our x-axis or number line. And in the middle, we'll do the mean, which is 6.1. And then to go 1 standard deviation away, we're just going to add 2 inches. So 6 foot 3, and then add 2 inches again, and then add 2 inches again. And then go to the left, we'll subtract 2 inches, subtract 2 inches again, and subtract 2 inches again. Then we can draw our bell curve in relationship to those spots. And then what you'll want to do, just to kind of help you remember what is what, you can fill in each little section with what percentage it represents. So this one's 2.35 and this one's 0.15. So let's write that down actually. You always want to start by drawing and labeling the curve. What is the probability that a player selected at random will be shorter than 5 feet 9 inches? So where is 5 feet 9 inches? 5 feet 9 inches is right here. And they want to know what's the probability of picking someone shorter than that. So everyone shorter than 5'9" lies within here. So we take these two probabilities and we add them up. And we get 2.5. 2.5% is the probability. The next question asks us if there are 240 players in this league, about how many players are taller than 6 feet 3 inches. This is asking for how many players. So we want a number, not a percent. But in order to find that number, we first have to find the percent. First, find the percent. Then multiply by number of players. How many players are taller than 6'3"? Well, that's all this area here. Okay, so we add that up, 13.5 plus 2.35 plus 0.15. So that's going to be 16% of the players are taller than 6'3". So remember, the next step is to multiply by the number of players. So we're going to do 0.16 times 240, and we get 38.4 players, or just 38 players are taller than 6'3". Let's look at another example. It says the number of eggs laid per year by a particular breed of chicken is normally distributed with a mean of 225 and a standard deviation of 10 eggs. So remember, the first thing we want to start with is drawing and labeling our curve. Okay, so the mean is 225 and a standard deviation of 10. Okay, so 225, 235, 245, 255, 215, 205, and 195. Okay, and in the middle there is going to be our center of our bell. Okay, and then we'll just draw a curve the best that we can. And then our percents, 13.5, this one's 2.35, and this one's 0.15. And you'll want to memorize these because we use them a lot. And then it just repeats on the left side. All right, about what percent of the chickens will lay between 215 and 245? Let's see, 215 is here and 245 is here. So what we'll want to do is kind of add up all of that space right there, right? So that would be 34 plus 34 plus 13.5, 81.5, okay, percent. Hopefully I did that math right. If a flock of 400 chickens, oh, that should probably say in a flock of 400 chickens, about how many would you expect to lay more than 245 eggs per year? So once again, we want to find the percent of how many lay more than 245 eggs and then multiply that by 400. 245 is right here. So this section is 2.5, 400 times 0.025. Okay, and then we'll get our answer. I'll let you do that in the calculator. Okay, and then that would give us the number of chickens that lay more than 245 eggs per year.